If you see white flakes on your shoulders, you might assume your scalp simply needs more moisture. But dandruff has very little to do with dry skin. It is actually the physical fallout of an invisible ecological collapse. The true problem starts here, at the stratum corneum. This is the outermost layer of your scalp. Think of it as a biological boundary wall, built with skin cell bricks and sealed tightly by a continuous layer of lipid mortar. When healthy, older cells detach one by one invisibly because the lipid mortar remains perfectly intact. A visible flake marks the exact moment your microscopic defense system fails. Your scalp is a bustling, living ecosystem, and like any ecosystem, it runs on a natural resource. Tiny glands constantly pump out a steady flow of sebum, a rich skin oil serving as the primary food source for billions of microscopic residents. Living right alongside each other, two main populations compete for this oily food: naturally occurring yeasts called Malassezia and dense clusters of resident bacteria. Under normal conditions, a dominant, highly protective bacteria called Cutibacterium acnes maintains order. By establishing a strong presence deep in the hair follicles, it actively suppresses other, more aggressive microbes that try to take over the territory. A specific, helpful species of Malassezia yeast assists in this defense. By sharing the space and resources, they ensure that no single group of microbes can hoard all the sebum. Healthy, flake-free conditions depend entirely on this perfectly balanced microscopic population control. This animated population chart shows what happens when that delicate balance fractures. When the protective bacteria line plummets, they lose control. In biology, we call this dysbiosis. Without bacteria holding them back, an aggressive yeast surges forward, multiplying to capture the vacated territory. Now massively overgrown, this bloated yeast population begins frantically consuming the scalp's available sebum supply. Here is where a biological flaw triggers a crisis. These specific yeasts lack the machinery to fully digest complex oils. They consume what they can and then violently expel the undigested leftovers directly onto the scalp as metabolic waste. This waste is a highly irritating free fatty acid known as oleic acid. This massive accumulation of acidic waste poisons the landscape, driving the actual damage to your skin. Sitting in concentrated pools on the surface of your scalp, this oleic acid acts as a potent biological solvent, directly attacking the boundary wall. The acid dissolves the protective lipid mortar holding your skin cells together, carving deep vertical fissures straight down. With the seal broken, deep cellular moisture rushes up through these cracks and evaporates. Clinically, this is called transepidermal water loss. Deprived of water, the top layers of skin cells rapidly dehydrate and die. Instead of shedding invisibly one by one, they fuse together into massive, jagged clumps that violently peel away from the scalp. That is what a dandruff flake actually is. It is the visible debris of a microscopic ecosystem that has entirely lost its water seal. For decades, traditional anti-dandruff treatments have relied on harsh chemical agents, designed to execute a total, non-selective biological wipeout. This heavy chemical wave certainly annihilates the overgrown fungi, but at the exact same time, it strips away the essential structural lipids of the scalp's barrier wall, leaving behind a barren, highly vulnerable surface. Because the physical barrier remains fractured and unsealed, the water loss continues. And the moment the aggressive microbes inevitably rebound, the flakes return. Long-term scalp health requires selectively managing the overgrown populations without destroying the environment's structural integrity. Modern dermatology achieves this using bio-based smart esters like propanediol caprylate. This molecule acts as an auto-regulating trap. To your healthy cells and protective bacteria, this ester is completely harmless. It only activates when an actively overfeeding yeast attempts to digest it. When the yeast's digestive enzymes make contact, it snaps the ester in half, instantly releasing a targeted antifungal acid. Looking back at the population chart, the overgrown yeast is suppressed. With the threat neutralized, protective bacteria safely repopulate, stabilizing the microenvironment. By supporting the natural microecosystem instead of simply destroying it, the biological barrier finally has time to heal. The lipid mortar solidifies, deep moisture is locked in, and the visible flaking naturally stops.